n from yesterday what that was?
Number
Number of trials? Very good. Number of trials. And P, remember that one?
Probability.
The probability of success. Probability of success. So in this case, the probability of success is what? The probability of getting a heads is?
0.5.
We're on the same problem as yesterday. What's the probability of getting a heads?
Oh,
Does it say 0.4, right? Right? 0.4. So P is 0.4, so the expected value of a head is n, which is, how many times am I flipping it? 5 times. So n is 5. And the P is 0.4, which will be equal to 2. So what we're saying is if I flip the coin 5 times, I would expect to get a head twice. I said the expected value of the number of heads I get if I flip 5 times. So this will be the answer to 1E for the expected value. They also want the standard deviation. And if you look right below, they give us the formula for standard deviation on our formula sheet. Standard deviation of x equals the square root of n times p times 1 minus p. This binomial will not be on the quiz tomorrow. Will not be on the quiz tomorrow. Bless you. So let's plug in what we know. So the standard deviation of a heads is equal to the square root, n is 5, p is 0.4, and 1 minus p is 1 minus 0.4, so 0.6. And this would go straight to the calculator. Right, this would go straight to the calculator, and we would get something like 1.0954. And this would be the standard deviation of the flipping of the coin 5 times. Giselle, do you mind turning the air down slightly, please? It's a little bit too hot. It's a little like lower. Yeah, maybe to 70 will be great. Appreciate it. Okay, so any questions on this much? Suddenly, I know you're a little bit lost, but the videos are there for you online. Okay, let's look at situation 2. So now we want to talk about geometric. So yesterday was binomial. Today I want to focus on geometric. So just like for binomial probability, geometric has 4 conditions that have to be true. There are 4 conditions for binomial. Geometric also has 4. Condition number 1 is that the events are independent. So the same condition as for the binomial. That's condition number 1. The events are independent. Second condition is also the same as for the binomial, that the probability of success remains the same. Remains the same. So again, this is like saying that every time I flip, it's always going to be 40% chance of getting heads. Number 3 is, and here's the difference. This is the difference. Binomial, I was flipping for 5 times, 10 times, a fixed number of flips. Geometric, I am let me put it in the example of this coins first, then I'll generalize. So you continue flipping until the first success. So in other words, I keep flipping the coin until I get a heads. So I don't know how many times I'm going to flip it. All I know is I'm going to keep flipping until I get a heads. So another way to say it a little bit more generally is you keep going until the first success. So you keep flipping the coin until you get a heads. Or you keep rolling the dice until you get a 1. Binomial says we're going to roll 10 times. How many 1s will I get? This says I'm going to keep on rolling till I get a 1. and we're going to talk about how many rolls will it take for me to get a 1. Slight distinction. And then condition number 4 says there is either a success or a failure. So this is just like binomial, either success or failure. So either you roll the heads or you don't. Either you roll a 1 on the dice or you roll anything else as a failure. There's either a success or a failure, no middle option. These are the 4 conditions for a geometric probability distribution. So very similar to binomial, except the only distinction is right here, that you continue going until the first success, as opposed to stopping after a fixed number of trials. Any questions on that? All right. So in a geometric situation, the formulas are not given to us on the formula sheet. The reason is because the AP exam has tested this only one time in the past 14 years. They're due to test it again. So we are predicting they're going to have it again this year. That's why we're teaching this.
This is what now?
This concept, geometric. So the formulas for geometric are the following. The probability that x equals k, and again, let's just get this down first, and then we'll go from there, is 1 minus p So let's copy this down, and then I'll explain in words what we're saying here. Let's just copy this down, and then we'll explain in words. So what we're saying here is the following. The probability of only having to flip the coin 10 times until I get ahead, or 20 times until I get ahead, or 30 times until I get ahead, or 100 times. This is the number of times I need to keep flipping before I get ahead. That probability is equal to what? Well, it's the probability that I don't succeed, k minus 1 times the probability I succeed once. In other words, if I wanted to find the probability that I get ahead on the 5th roll, like H's, the probability I get ahead on the 5th roll, that's saying what? Well, that's the probability that what? I got tails, 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 then heads. This is really saying, what is the probability of this happening? That I don't get my first heads until the 5th roll. That's what this is saying. Shamar.
The variables are the same as binomial, like
Yes. So this is saying, what is the probability that I get a heads on the 5th roll? Well, it's the probability that I don't get a heads, which is 0.6, 4 times. Right? I got to not get a heads 4 times, and then get the heads, which is 0.4. So k is how many times does it take me? K minus 1 is, of course, k minus 1. 1 minus p is 1 minus the probability of success. P is probability of success. Karina. 1 minus 0.4 equals 0.6, right? Victoria? Yeah, so it's 1 minus 0.4. Because it's saying 1 minus p. P is the probability of success. So the probability of getting a heads is 0.4. So 1 minus 0.4. So on the next line, probability that x equals 5 equals 0.6 to the 4th power times 0.4. This would be the answer to part H, which would be 0.0518. This is straight on the calculator. Let me stop here and take the question.